Question 5. Find the optimal double exponential smooth model to predict sales for time period 2 to 20. Calculate MAD, MAPE, and MSE. Double exponential smoothing model is also called Holt's model. Here are the formulas for double exponential smoothing model. As we can see over here, once again we need some parameters, alpha and beta. And once again, for convenience, let's say alpha is 0.5 and beta is also 0.5. And later on, we're going to use solver to find the optimal alpha value and beta value for our model. Okay, let's look at one of those formulas. For example, ET. E is once again the base level. In order to find base level for, say, time period 1, we need what? E0 and T0. And we don't know where they are. So, as usual, we're going to do something called initialization. And by convention, the first base level will be equal to the very first actual sales number. And the trend is nothing but the difference between those two. Of course, because actual sales equals the base level, the trend will be 0. After the initialization of the model, let's see what we can do next. Okay, now we can use the formula listed over here to calculate E, or the base level, or the T trend. First one we can actually calculate is indeed E2, base level of time period 2. It's going to be equal to alpha, absolute sale reference, times the actual sale of time period 2, or Y2, which is 25, plus 1 minus alpha times E sub t minus 1 plus t sub t minus 1. That is nothing but E1 plus T1. So E1 right here plus T1 right here. Okay, we'll click return. To calculate the trend, let's use the second formula over here. Trend of time period 2, or T2, is going to be equal to beta, absolute sale reference, times E2 minus E1, because T is equal to 2. E2, the number we got a second ago, minus E1 plus 1 minus beta times T sub t minus 1. Little t is 2, so little t minus 1 is 1. Here we are looking for the trend from time period 1. Right here. Return. Similarly, let's make sure those numbers are integer. Okay, indeed, we keep 0 decimal place. We're good to go. Alright, let's see how we can make a forecast. The first forecast we can actually make is actually for time period 2. And look at the formula number 3. Y2 hat will be equal to most recent time period 1, E1. Is it available or not? Yes. So Y2 hat will be equal to E1 plus 1 times T1, because it's just one time period into the future, from time period 1 to time period 2. So here it's going to be equal to E1 plus T1. And the way to calculate E, AD, APE, and E squared are just the same. Forecast error is equal to actual sales minus forecast. AD is just the absolute deviation or the absolute error. APE is the absolute value of forecast error divided by actual sales. In the end, the squared forecast error is forecast error squared. And then we can copy and paste the formulas for all the other remaining time periods here there. Alright, but we're not just done yet. You see over here, once again, we would like to predict sales for time period 2 all the way to time period 20. Okay, we got the information up to time period 16 at this point. What about the forecast for time period 17? So Y17 hat will be equal to what? E16 base level from time period 16 plus 1 times trend in time period 16. Because right now we are sitting at time period 16 and we would like to predict the sales for time period 17. So it's 1 time period into the future. So n is equal to 1. But what about the prediction for time period 18? You see, E17 base level of time period 17 is not available. The best we can do is to use the base level from time period 16 once again, the most recent one that is available. But right now, we're talking about what? 2 time periods into the future. We want Y18 hat, but the most recent base level we have is E16. So T is equal to 16 and T plus N is equal to 18. As a result, N is equal to 2. E16 plus 2 times, once again, the trend we have, the most recent one we have is T16. And similarly, the forecast for time period 19 will be equal to what? E16 plus 3 time periods into the future times T16. Last but not the least, prediction for time period 20 will be equal to E16 plus 4 time periods into the future times T16. And this is how we use double exponential smoothing model to make predictions. And next, let's finish MAD, MAPE, and MSE. Like we've been doing so many times, MAD is the average of all those ADs. MAPE, the average of all the APEs times 100, and MSE is the average of all the squared forecast errors. And similarly, we're going to use solver to find the optimal alpha value and beta value. Click solver. Once again, let me reset it. Objective is nothing but our MSE in cell J24, which we would like to minimize. And how to do that? By changing alpha value and beta value. Constraints: alpha, beta are between 0 and 1. And check this box. Make unconstrained variables non-negative. Now we're ready. Selecting GRG nonlinear method and then solve. Keep solver solution. Here's what we find. The optimal alpha value is 0.061 and the optimal beta is 1. As a result, the minimal MSE value is 57.